Okay, so in this video, we're going to go through sample question 85 from the Society of Actuaries ExamP list of sample questions. The question reads, the total claim amount for a health insurance policy follows a distribution with this following density function. The premium for each policy is set at the expected total claim amount plus 100. If 100 policies are sold, we need to calculate the approximate probability that the insurance company will have claims exceeding the premiums collected. Okay, so this is a really good example of use of the central limit theorem. How do I know this? We're given information about each individual item, you could say, and we're asked to find information about a group of identical and independent items. Right? We're identical, independently distributed. We can apply the central limit theorem. So if we look here, we have that the total claim amount for one policy has this density function. We're going to need to find the expected value as well as the variance and standard deviation for this policy. Now, you can actually calculate, you're given a density function, there are formulas to calculate that, but that's super unnecessary in this case because you should 100% recognize this distribution. If you haven't tried out the problem already, I would suggest just pausing, see if you could figure out what distribution this is. It's one of our memorized ones. And that's the thing about memorized distributions. Sure, sometimes they'll say, hey, this thing follows a binomial distribution. This thing, has a gamma distribution or is uniform normal. But sometimes they'll give you a density without telling you what kind of distribution it is, and you should be able to recognize that this is an exponential distribution. It follows that formula of 1 over theta, right, times e to the negative x over theta, where theta is my expected value. So for this, my expected value of x is 1,000. And the variance is theta squared. So the variance of x is 1,000 squared. And the standard deviation would then also be 1,000. So now that we've got that out of the way, let's look at our next bit of information. The premium for the policy is set at the expected total claim amount plus 100. So the premium, P, right, makes sense to call premium P, is equal to the expected total claim amount, which is E of X plus 100, which happens to be 1,000 plus 100, which is 1,100. And there we go. Okay, so now we're told 100 policies are sold, and we need to calculate the approximate probability that the insurance company will have claims exceeding the premiums collected. Okay, so the probability that the total amount of claims, which I'll just represent as T, right, exceeds the premiums they collect. So I'll just say total P. All right, that's what we're looking for. So we have information about individual premiums. We need to find out information about this total, right? That's going to be that's going to involve finding our expected value as well as our standard deviation, right? Because we're applying the central limit theorem. Well, sorry about that cut. I misspoke on something. So we want information about the total. Well, we want to figure out the approximate probability that the insurance company's claims will exceed the premiums collected. Well, what's the premiums they collect? If they collect 1,100 on each individual person and they got 100 people, the total amount of premiums, right, total P should be equal to 100 times 1,100, which equals 110,000. So we're looking for the probability that our total exceeds 110,000. Now, in order to do this, we need information about t. We need the expected value, we need the variance, we need the standard deviation. So our expected value should be equal to n, which is the number of items we have, in this case number of claims, multiplied by the expected value of each individual, which is equal to 100 times, what's the expected value of each individual is 1,000, and that is equal to 100,000. Nice and easy. Now, the variance, right? We need to calculate the variance and then use that to get the standard deviation. That is also n multiplied by the actual variance of each individual. So that is equal to 100 times 1,000 squared. And just to make sure I'm doing that correctly, I'm going to punch that into my calculator. 100 times 1,000 squared. And that is a very large number. $100 million. Okay. And then I take the square root of this in order to get a standard deviation of 10,000. Okay. Now that I got my two important, numbers, right? I have this thing here and this here. I'm going to get the standard normal. I'm going to use the standard normal distribution to actually calculate this probability. Now, here it is in a different color. We're going to calculate a z-score. X minus my expected value divided by my standard deviation. That's what I'm going to be using. So, taking this, I'll rewrite this here. The probability of my total being greater than 10,000, which, since the table we're going to use to actually find probability is actually cumulative, it's a CDF, I need to use a t less than in order to make this happen. So the way I'm going to do this is just write it as 1 minus the probability of t less than 110,000. Okay, now I can standard normalize this. This is 1 minus the probability of t minus the expected value, which is 100,000, all divided by 10,000, which is my standard deviation. Mainframe, yep. There we go. And that's got to be less than 110,000 minus 100,000 over 10,000. And that's equal to 1 minus p. This is just, I'm going to write this as z, because we're doing a z-score. And this becomes just 10,000 over 10,000, which is just 1. Oh, sweet, nice and easy. So this is, I believe this is the symbol phi of 1, which I'll go to a standard table. Now, the one I have has negative values. This question doesn't actually involve negative values, but your table will not have negative z values. Know how to actually find the z value of negative 1.67 or something like that, right? Not too difficult, but important to not get messed up. Okay, so right here, the z value for 1 is 0.8413. And if I were to subtract That's going to be 0.159, I believe. I can actually 1 minus 0.8413. Oh, right, because I just kind of looked at this and saw only answer choice B gets really close to whatever number this is supposed to be, and I was correct. But it's actually rounded, which is approximately 0.159, which is answer choice B. Okay, so let's go over what happened here. First, I identified, okay, we're given a bunch of individuals and we're asked a question about their total. Great, I'm using central limit theorem. So in order to do central limit theorem, right, we need to find for the total the standard deviation and the expected value and the variance. In order to get that for the total, I need to know that those pieces of information for the individual. So each individual, we're given this PDF. I saw, great, exponential distribution, 1,000 is my expected value, 1,000 squared is my variance. Using that, I found the expected value and the variance and standard deviation for my total. And then I applied it and figured out my z-score. And then something that this question had that a few other questions might not have is just this middle bit, right? Where it doesn't exactly tell you, hey, what's the probability that the insurance company will have claims that exceed and then they give you a number. In this case, they didn't give you a number. They said the premiums collected, and they told you information about the premiums. And we have to actually find the actual number that we needed to calculate the probability of being greater than, right? But that's pretty much it. Important topic, central limit theorem, normal distribution, that you're going to have quite a few questions on those. If you have any questions, throw it down in the comments. I'll answer to the best of my abilities. If this video helped you out, hit the like button, subscribe. That very much helps me out. And if you want to see more videos like this, I got a playlist, adding more to it as we speak, or as I speak. Hopefully it's already done by the time you're watching this. I got a playlist. But other than that, thanks for watching, and I hope this helped.